This video will cover covalent bonding, so I'm going to go through covalent bonds, dative bonding, polar covalent bonds, and polar molecules. So covalent bonds are where we have a shared pair of electrons between two atoms. So for example, if we have the H2 molecule, there's two electrons in the bond and one electron came from each of the H atoms. So there are just a few general things to remember about covalent bonds. So covalent bonds are strong. Covalent compounds tend to have low melting and boiling points, so they can exist as solid, liquid or gas at room temperature. And most covalent compounds don't dissolve in water, but are soluble in organic solvents. Okay, moving on to coordinate or dative bonding. Dative means to give. And this again is where we have a shared pair of electrons between two atoms, but both of those electrons from the shared pair have come from the same atom. Once a coordinate bond is formed, it is identical to a covalent bond. So if we just go through an example, if we take the reaction ammonia reacting with H plus to give the ammonium ion NH4 plus. So if we represent that reaction using a dot and cross diagram, you can see that the nitrogen in ammonia has a lone pair of electrons and H plus has no electrons. So the lone pair on the nitrogen gets donated to H plus to form a coordinate bond. So both of those electrons in that bond have come from the nitrogen. The important thing to remember is that all four bonds in the ammonium ion are identical, even though the origin of the electrons are different. So the requirements to form a coordinate bond are: we must have a species that's got a lone pair of electrons to donate. So in this case, the nitrogen had the lone pair of electrons. And we must also have another species that's got an empty orbital in order to accept that lone pair of electrons. So in that example, that was H plus. Okay, moving on to polar covalent bonds. For example, if we had the molecule diatomic bromine, the bromine-bromine bond is non-polar because the bromine atoms have the same electronegativity, so each atom has the same share of the electrons in the bond. If we take another example, bromomethane, now we've got the carbon-bromine bond that's polar, or we say that it has a dipole, and this arises because bromine is more electronegative than carbon, which means that the bromine can draw the electrons in the bond more towards itself. And to represent a polar bond, we use the notation delta plus and delta minus to show the direction in which the electrons are being pulled towards, or we can use the arrow on the carbon-bromine bond. So moving on to polar molecules, if we just use the same examples again, in diatomic bromine, that is a non-polar molecule because there's no outer part of the molecule that has either delta plus or delta minus compared with the other parts, so that's just got the same charge all over. Going back to bromomethane, this is a polar molecule because one part of the molecule is delta plus and another part is delta minus, and the centre of the negative charge does not correspond to the centre of positive charge. Final example, if we have tetrabromomethane, even though it's got 4 carbon-bromine bonds, so all of them are polar bonds, the molecule as a whole is non-polar because the centre of positive and negative charges correspond due to the symmetry of the molecule.